Hey there, are you tired of your thermodynamics teacher telling you a process isn't possible and you just don't know why?
Man, I just don't understand this.
Me neither.
Well, today's your lucky day because I'm gonna tell you.
Break nine, the thermodynamics. Break.
So really, it all boils down to this thing called the second law of thermodynamics. And it basically says that energy will spontaneously disperse itself in different forms to try and reach this state of equilibrium. Now this sounds weird, but if you look at it in terms of something a little bit more realistic, it makes more sense. Say we had this piece of ice in this hot room. The heat, or the energy of the room, wouldn't want to stay in one place and leave this cold piece of ice alone. It would want to spread itself out and make everything in the room the same temperature. That's why the ice melts.
No way!
Now that's just looking at it on a small scale. Let's look at it on a larger scale. Let's say the largest scale possible. The universe! Now if energy wants to spontaneously spread itself out like we were talking about earlier, then that should mean that the energy of the universe should want to spread itself out too, right?
I guess.
So what's the point of all this? Well, we measure this value with a term called entropy. Now it sounds weird, but it's simply just to measure this spontaneous dispersal of energy. Now if we said that the energy of the universe is always expanding, then shouldn't the entropy, which is the measure of the spontaneous dispersal of energy, always be going up as well? Well, we call this term the entropy generated, also known as SGen. If your entropy generated is negative, then you just said that the entropy of the universe is somehow decreasing, and that's some bad stuff. Now if we apply this stuff to our thermodynamic situations and find the value of SGen, then we'll know if this situation is even possible. Now you should know what your teacher is talking about, right?
Yeah!